Hey Algebra 2, today we're going to take what we learned the other day about condensing and we're going to apply that and we are going to solve more complicated log equations. So, anytime that you have addition or subtraction or multiplication, you have to condense it. So I have log plus log on the left. So the first thing that I have to do is condense. And that addition there is condensed via multiplication. So I'm going to multiply the 4x and the 5. So I have log base 2 of 4x times 5 equals log base 2 of 20. I'm going to finish multiplying that and get 20x equals log base 2 of 20. So the parentheses aren't completely necessary, but it gives me a good visual so that I know and understand that this is all together as one single term. Okay, so now I have an equation that I should know how to solve from, I don't know, a couple lessons ago. So when you have log equals log, you're going to drop log and solve. So those are the same, so I drop them, so I get 20x equals 20 divided by 20 and get x equals 1. So the only thing that you need to do is you need to make sure that when you plug the x in that you're not taking the log of a negative number. So that would be log of 4, because 4 times 1 is 4, and that looks pretty good to me. Number 2. On the left, I have log plus log. So I'm going to condense that with multiplication. So I have log base 3 of x times x minus 4 equals log base 3 of 12. I'm going to distribute to clear parentheses. So I have log base 3 of x squared minus 4x equals log base 3 of 12. Now I have it to log equals log, so I'm going to drop the log and get x squared minus 4x equals 12. So I see on the left I have a quadratic. I know my quadratics need to be set equal to 0. So I get x squared minus 4x minus 12 equals 0. I'm going to make an ACB chart, and I need factors of negative 12 that add to negative 4. I know those numbers are negative 6 and 2. So x minus 6, x plus 2 equals 0. Set each equal to 0. X minus 6 equals 0. X plus 2 equals 0. Do algebra and solve, and x equals 6. And x equals negative 2. Alright, so you can't take the log of a negative number. So if you look here in the original equation, if x is 6, then log base 3 of 6, that's fine. 6 minus 4 is 2, that's fine. So 6 is a good answer there. Now you look at the negative 2. Log base 3 of negative 2. So you can't take the log of a negative number. So once again, when you check it and you plug it in, you would have log base 3 of negative 2, etc., etc. You can't take the log of a negative number, therefore, this is not a good answer, and it is what we call extraneous. On number 3, I have subtraction. I know that I condense via division. So this gets me log base 3 of 56. I'm tired of using other variables. I'm going to just use an x instead of an n. Equals log base 3 of 7. So you have log equals log, so I'm going to drop log. And I have 56 divided by x equals 7. I would probably end up putting that over 1. When you have fraction equals fraction, I would probably just cross multiply. Get 56 equals 7x. Divide. and x equals 8. And when you glance there, yep, that doesn't get you a negative number, so that is good. On number 4, we have a lot going on. So we have multiplication in 2 different places. So I'm going to move that to the exponent. So I have log base 4 of x equals log base 4 of 81 to the 1/4 plus log base 4 of 25 to the 1/2. All right, so I know that I can simplify this because I know that you could take the 4th root of 81. If you aren't quite familiar with that, I invite you to put that into your calculator. So I would go 81 raised to the, do parentheses, 1 divided by 4, and that is 3. So I have log base 4 of 3 plus log base 4, 25 to the 1/2. So I have, no, we don't, hold on, 25 raised to the power of 1/2, so that would be 1 divided by 2, and that is 5. Log base 4 of 5. All right, so now I still have a plus sign here, so I still have to condense. So I have log base 4 of x. We condense addition by multiplying, so I'm going to take 3 times 5 and get 15. Log base 4 of 15. I have log equals log, so I'm going to drop the log and solve. And that's how I got x equals 15 for a good answer on that one. Let's see, number 5, you just need to condense, and yeah, we haven't done one like that yet. I have subtraction, so I'm going to condense that by division. So I have log base 2 of 2x plus 6 divided by x equals 3. All right, so we've done these before. We are in the situation of log equals number. When log equals number, you are going to change form. And what I mean by change form is you have a log. I suggest you change this into an exponential. So when I change this into an exponential, my 2 comes down, my 3 goes to the exponent, and the 2x plus 6 over x all goes to the other side. I know that 2 to the 3rd is 8. I would probably put that over 1. I have fraction equals fraction. I would cross multiply. 8 times x is 8x. Anything times 1 is that. I'm going to subtract the 2x over. Get 6x equals 6. Divide. And get x equals 1 for a good final answer on that one. Number 6, I could see doing this 2 ways. The first way that you would do it is I have a 3 out in front. A 3 goes to the exponent. So this would be log base 2 of x to the 3rd equals 6. I have log equals a number. You might want to put parentheses around x to the 3rd to know that that is functioning as 1 unit. When I change this into exponential, my 2 comes down, 6 goes to the exponent, next to the 3rd to the other side. 2 to the 6, I used my calculator and I found that that's 64. I need to get rid of this exponent, and so roots get rid of exponents. So I'm going to take the cube root of both sides, and I know the cube root of 64 is 4. So x equals 4 is a good answer. Or, let me show you another approach. 3 times log base 2 of x equals 6. So when you have a plain old number over here, and right here this is multiplication, that says 3 times the log. It would be okay if you divided both sides by 3 to get rid of that coefficient. And then you just have log base 2 of x equals 2. And then from there, I would change form because I have log equals number. This 2 is my base, this 2 goes to the exponent, and the x goes to the other side, and 2 squared equals 4. When I see 7 and 8, all right, so on 7, I have a number here and I have a number here. So in the past, I've tried to write them, tried to get the same base. So I can't take any number to an exponent and get a 6. I can't take 2 to a power and get a 6. I can't take 3 to a power and get a 6. So when you can't write them using the same base, your mantra is to change form. All right, so when you change form, in exponential, you have b to the y equals x. That would be log base b of x equals y. All right, so this 6 right there, that's playing the role of my b. That complicated exponent, that's playing the role of my y. And this 50 is playing the role of my x. So that when I change form into log form, I get log base 6 of 50 equals x minus 2. So I did that because when I have a number here and a number here, you can use your change of base formula to solve and figure out what this is as a number, probably rounded to 4 digits. So I have log 50 divided by log 6 equals x minus 2. I took this in my calculator and I got 2.1833. So let's get in the habit of rounding to 4 decimal places on these. We're going to add 2 to both sides, and this is 4.1833 equals x. Should be your good final answer on that one. All right, so if you wanted to check it, you would have 6 to the 4.1833 minus 2, and hopefully that is about 50. When I subtract, I get 2.1833. I entered that in my calculator and I got 49.9963, which is close enough. So yep, that is the good final answer. On number 8, I have a 2 and a 5. I cannot write 5 as 2 to some exponent. So if you can't do that, then change form. Try to change it into a logarithm and see if you can work with it. So when you have b to the y equals x, for the b to the y, so they each have an exponent, and you're like, I don't know if it should be the 2 to the x or the 5 to the x plus 2. We're going to use the more complicated as your b to the y. So this right side with the x plus 2, I'm saying that's the more complicated one. So this 5 right there, that plays your b. The x plus 2 is your y. And 2 to the x is your x. So when I change form, I'm glancing here at this other one. So I have log base 5 of x, which is 2 to the x, equals y, which is x plus 2. Okay, so you have to figure out, if I could get rid of this x, if I could get rid of this exponent, then I would have a number in here, and I could use the change of base formula. So here's what you do. We are reversing and undoing the how we usually condense multiplication into an exponent. We're doing the reverse of that one right now. So this x goes to the front, and now it becomes a multiplication. X times log base 5 of 2 equals x plus 2. So this portion right here, now I'm going to do the change of base formula on it. So I have log 2 divided by log 5 equals x plus 2. I entered this in my calculator, and I got about 0.4308. It would be customary to put your coefficient first, so I'm just going to rewrite it as 0.4308x equals x plus 2. So I have to solve for x. You need to know that there's an implied 1 there, so I'm going to subtract 1x from both sides. 0.43 minus 1 is negative 0.5692x equals 2. So I have multiplication. I'm going to divide both sides by negative 0.5692. And that is approximately negative 3.5137. You could plug it in and you could check your work and you could see that it is a correct answer.